For learning how to use a voltmeter, let's first take a look at all the holes, the buttons, and the knobs on it and get a brief explanation of that. The holes on the bottom are for the test leads. The one labeled common as black is always going to be for the black test lead, which is the negative side. The yellow ones labeled 20 amp and microamp milliamp are for measuring current. Those will be for the dial selections on the far right. Those aren't the most commonly used. We'll cover that later. For the high impedance input is the red lead right here for volts, ohms, hertz, capacitance, degrees, diodes, continuity, the whole match. So for the most part, unless you're doing current measurements, you're going to have the red test lead plugged into that hole. The selector knob has got all the functions in it, and they've alternated colors on it to make it clear to see what you're doing. So the knob selection is for volts, and it has a squiggly line and a flat line. The flat line represents DC volts and AC volts, so it's going to be the same selector. If we like millivolts, millivolts are 1,000 volts AC DC. Ohms is for resistance. The little beep thing is for doing continuity checks. It beeps at you. And then the diode checker is a way to check diodes for forward voltage drop and to make sure that they're not shorted. This is the capacitor test. The next one says hertz percent. That one is for measuring frequency and duty cycle. Temperature is the next selector switch. The selector switch that says NCV is for non-contact voltage. The next ones that have a flat and squiggly above them are microamp, milliamp, and amps. For those things, you need to use this hole here for the positive lead. Up here on the digital multimeter, we have buttons for select, range, a light, then it says hertz, duty, and then Bluetooth. So, of course, to activate and see how those work, you have to turn it on. Just to go over each and every one of them, we turned it on, and it beeps to say that. It's okay. So this is the volt selection as for either AC volts or DC volts. If we kind of bring that up a little closer to the screen, if you hit the select button, it changes to AC or DC volts. Okay, and then the range select, even though this is selected that you can do auto range, you can also select what voltage range you want. So it gives you more detail. So there's volts, it says over there, you hit select. It moves a decimal point over here for a whole bunch of digits. If you want to use all the digits, that would be for millivolts. This would give you one place in front of the decimal point. This would be 3 below. And it just shifts over to the kind of resolution you want. And the same thing if we select for AC, does the same thing, selects the range. And as you can see, it move around. Okay, do millivolts, exactly the same thing. Select AC, DC, or select the range you want. Ohms selection is okay. This selection's for ohms. And go through the range. No, actually this one's different. We just select ohms, and then the volts shows up for diodes, for diode checker, and then we have kilo ohms and mega ohms. Okay, and this is the continuity tester. I'll just show that real quick. I'll touch the motor lead, the test leads, and you can hear that the continuity is sending a beeper that says it reads continuity. Okay, the next selection is for capacitors. So we hit the select button. It doesn't need to select anything because that's the only thing that's there. And then we can hit the range button and it's going to auto range. Okay, the next selection is for hertz and duty cycle. So we notice that the range and the frequency don't change with the select and range button, but there's another button over here that says hertz and duty, and that's between reading frequency, hertz, and then the percentage duty cycle. Now we see if we hit the other buttons, it's not really doing anything. Okay. And then for the degrees C, degrees F, that's selecting you have a temperature probe that comes with the meter. Non-contact voltage is for reading voltages, whether they're the presence of them or not. It will not show you a value, and we'll demonstrate that later. And then microamps, milliamps, and amps, we need to read current, and we would have to move this probe to one of these so it matches. Microamps would go to this one and this hole where it says microamps, milliamps, so it's pretty easy to see if you match those up. And the same thing with the select button. You're going to select AC or DC. And then if you were going up to amps, you would go to 20 amps if you're going into an amp range that's above milliamps. And you notice that they have fuse markings on what the limits are. So if I will turn this over, the microamp milliamp hole says maximum 200 milliamps. It's fused. If you exceed 200 milliamps for very long, it's going to blow the fuse. And there's pictures about where those fuses are, but you have to disassemble the meter, which is pretty common, to change those fuses. You don't want to do it. And then the same here, this is a maximum 20 amps. It's got a fuse in it. So you want to make sure that if you got something bigger than 20 amps, you're going to use a different type of meter. Okay, a couple other things that I'll mention about the buttons. You've seen as we've turned the knob that we have different versions. We can have selections and ranges, hertz and duty. We never did hit this button, and this button that turns on the hold. So if you're reading a value and you want to hit it and hold that value, so you can take your meter back and don't have to write it down, you can hold that value. And if you hold this down a little bit further, it turns the backlight on. The backlight also serves as a flashlight. So if you're back in a corner and you need to see something, it's really handy to have. Okay, so I'll hold that and clear those out. And you notice the flashlight you have to hold it down a little bit longer to clear that out, and the hold was just a quick one. One other thing with the button, the hertz duty cycle button also has this little Bluetooth squiggly. If you hold it down, it turns the Bluetooth on, and then you can connect with your PC or your meter. So that was a quick introduction of all the buttons. Thank you. Another really handy feature of DMMs, digital multimeters, and digital voltmeters, especially the ones that are portable, we're going to flip it over real quick, and there's always a little lever in the back, which is really handy for standing your voltmeter up, which is a good way so at least you can see it without having to bend over if you're working on a job and probing different parts. Not sure if you can read that or not. This makes a note of the Cat 3 maximum 1000 volts on there. Another interesting thing on these test leads, I don't know if you can read it very well on here, it says maximum 10 amps. So take note that although you have a 20 amp circuit ammeter, the test leads that came with the packet will not do 20 amps. They're only good for 10. For the next thing I wanted to test with the voltmeter, these are the test probes that are native to the package coming out, and they've got very, very sharp test leads for putting on circuit boards, things like that. I didn't really want to use those. I want to do a capacitor test, and trying to get these things on a capacitor is not very productive. So we have an option with the meter. They came with these clips, so we don't have to change to a different style of test lead. We can just change these and modify them. I pulled the alligator clip out, and then I'm going to twist off that cover, and lo and behold, it exposes more of that test lead. I want to put it back in just to I want to put it back on just to show you right here. There is a threaded portion to these alligator clips. So what we'll do is, I'm going to put the rubber sheet back on, but they screw back onto those test leads. Don't lose this part though. Keep track of it so that you can use that again. But the idea is that now we can convert those test leads to alligator clips and make our job a lot easier for testing the capacitors. Oh, it wasn't on the screen, so let me show that again. So I inserted this alligator lead back into the boot, and then I can look down inside and see where it is, make it up, and then screw it on, making sure that we've got a good there we go. Got in there good now. And we'll tighten that up. There we go. And now I'll bring the boot up. Now we can put our test leads onto bigger things and studs and stuff like that. And we'll repeat and do the same thing on the red one.